In this video, I'm going to run through the answers to exercise 2 from 5.3, but I'm only going to focus on the dot and cross diagrams. So in order to draw the dot and cross diagrams, there's a few things that's important to keep in mind. Anytime you're drawing a dot and cross diagram that involves hydrogen, hydrogen should end up with 2 electrons in its outer shell. This means that hydrogen is only ever forming one covalent bond. Remember, a covalent bond is a pair of electrons or 2 electrons. So if you want hydrogen to end up with 2, you should only ever be drawing one covalent bond for hydrogen. With your period 2 elements that form covalent bonds, and remember it's your non-metals forming covalent bonds, so I'm looking over on this side of period 2. With your period 2 elements that form covalent bonds, they will all end up with 8 electrons in their outer shell, so a full second shell. The exception to this is boron, and I'll come back to boron later. But the rest of them that form covalent bonds, so I'm talking about carbon, nitrogen, oxygen, and fluorine, they all form covalent bonds. They all end up with 8 electrons in their outer shell, or a full second shell. In period 3, the elements that form covalent bonds can have a maximum of 18 electrons in their outer shell, and they will form a different number of covalent bonds. For example, something like phosphorus can form 3 covalent bonds, or it can form 5. Okay, as long as it doesn't exceed 18 electrons in the outer shell, it can form a different number of bonds. How will you know how many bonds? You just look at the compound and look at how many atoms it's bonded to. Similarly, sulfur and chlorine can form a different number of bonds as long as they don't exceed 18 electrons in the outer shell in total. So if we have a look at the first one that I gave you to do, which was NH3. So I've just broken it up here. Nitrogen is the element that you only have one of, and that's going to be at the center of your dot and cross diagram. And if I have a closer look at nitrogen, I see that it's in group 5 and it's in period 2. Because it's in group 5, it's got 5 electrons in its outer shell. However, if it were to form 5 covalent bonds using those 5 electrons, it would end up with 10 electrons in its outer shell, each bond being 2 electrons, 5 bonds, 10 electrons in the outer shell. Because nitrogen's in period 2, it cannot have 10 electrons. That means it's only going to be forming 3 bonds, okay? Because if it forms 3 bonds, it gets 3 electrons plus the 5 it already has. In this case, NH3, it's quite obvious that it's only going to form 3 bonds because it's only bonded to 3 hydrogens. So I just drew it out like this first before drawing the dot and cross. Hydrogen only wants to have 1 bond. Each hydrogen has 1 bond. Nitrogen wants 3 bonds. Nitrogen has 3 bonds. And this is what your dot and cross looks like. Remember, nitrogen does have 5 electrons in the outer shell. 3 of those electrons are involved in bonds. 2 of those electrons are not involved in bonds. And again, the reason why, if nitrogen used those electrons to form 2 more bonds, it would end up with 10 electrons in the outer shell, which is too many for a period 2 element. On the other hand, if we look at another group 5 element, phosphorus, we'll see that it's slightly different. Phosphorus, like nitrogen, is in group 5, so has 5 electrons in its outer shell. However, phosphorus is in period 3. And because it's in period 3, it can use all 5 of its electrons to form 5 bonds. Now, how do I know if it's actually forming 5 bonds? Well, I just look at the formula. Here I've got PCl5, I've got 5 chlorines bonded to phosphorus, and that's absolutely fine because phosphorus is in period 3 and can form 5 bonds. You're not going to find NH5, nitrogen can't form 5 bonds, but phosphorus can. So to draw the dot and cross for that, phosphorus is in group 5, it's got 5 electrons in its outer shell, so I'm going to draw 5 dots around phosphorus. It's then bonded to 5 chlorines, and I use chlorine has got 7 electrons in its outer shell. It uses 1 electron in bonding. Chlorine's other 6 electrons stay on chlorine. So it's a little bit tedious to draw all of chlorine's lone pairs, but you do have to do it to get the marks. The next example we look at, H2O. So I'm focused on oxygen here. It's in group 6. It's in period 2. It's got 6 electrons in its outer shell, but because it's in period 2, it can only form 2 more bonds. Okay, if it were to form another 6 bonds, it would end up with 12 electrons in its outer shell. That's too many for a period 2 element. It's only going to form a max of 2. If we look at the formula, we can easily see that yes, indeed, oxygen is forming 2 bonds because it's bonded to 2 hydrogens. Hydrogen can only form 1 bond. This is what your diagram for H2O should look like. If we look at another group 6 element though, sulfur, here it's in group 6, so like oxygen has 6 electrons in its outer shell, but because it's in period 3, it can form up to 6 bonds. In this case, it's forming 4. It might form 2, it might form 4, it might form 6. You'll figure out how many it's forming from the formula, but just be aware that it's totally fine for sulfur to form 4 bonds. It's in period 3. As long as it doesn't exceed 6, it's fine. So here I've got sulfur, 4 fluorines around it. To draw the dot and cross for that, I've got fluorine, 4 fluorines surrounding sulfur. But remember, sulfur does have 6 electrons in its outer shell. I've only drawn 4 dots at the moment, so sulfur does have 1 lone pair of electrons, okay, that are not involved in bonding. So I've drawn 6 dots in total. 4 of them are involved in a bond with fluorine. 2 of them just remain sitting on sulfur. You then have to fill in fluorine's remaining electrons. Fluorine's in group 7. 7 electrons in total means that around each fluorine there should be 7 crosses. If we flip over to the next page, have a closer look at fluorine. So here I've got HF. Fluorine's in group 7, but it's in period 2. So even though it's got 7 electrons in its outer shell, it cannot form 7 bonds. It can only form 1 because the outer shell cannot exceed 8 electrons because it's in period 2. Here anyway, we can just see it's forming 1 bond with hydrogen, HF. It's going to look like this. If we look at another group 7 element though, chlorine, I'm forming ClF5, so chlorine in this case is forming 5 bonds, and that's absolutely fine because chlorine's got 7 electrons in its outer shell, and because it's in period 3, it can form a maximum of 7 bonds. In this case, it's only forming 5, and I know that because there's 5 fluorines around it. So I'm just going to draw chlorine's electrons, so I've got 5 fluorines around chlorine. So the crosses here are representing chlorine's electrons, 1, 2, 3, 4, 5, okay, but it does have 7 electrons in total, meaning chlorine is going to have another 2 crosses that just sit on it, not involved in bonding. To finish this off, I would need to put 6 dots, another 6 dots around each fluorine, okay, which I'm not going to do, but you absolutely have to do that. In question 5, I ask you why boron forms BF3 and not BF4. Okay, so boron is in group 3. That means it's got 3 electrons in its outer shell, and that means it can only form 3 bonds. It doesn't have any more electrons. It's only got 3 electrons in its outer shell, which means it can only form 3 bonds. So I think I asked you about fluorine, I can't remember. It can only form 3 bonds. This makes boron an exception to the rule I talked about at the start. I said all of your period 2 elements will end up with 8 electrons in their outer shell. This is true for carbon and oxygen and nitrogen and fluorine, but it's not true for boron. Okay, boron, when you draw it out, only ends up with 2, 4, 6 electrons in the outer shell, and the reason it only has 3 electrons, it can only form 3 bonds, even though it doesn't end up with 8 in its outer shell. The next example I have here is SO2. So we've already looked at sulfur and oxygen, so I'm not going to rewrite all of that again, okay? I'm going to put sulfur in the center because I've only got 1 sulfur, and I'm going to put an oxygen on either side, so I've drawn my SO2, okay? I'm going to draw a bond between sulfur and bond between and the bond between the 2 sulfurs and the oxygens. So if I look at what I've just drawn, I've got sulfur with 2 bonds, okay? Sulfur is in group 6, period 3, okay? That means sulfur can have a maximum of 6 bonds, so as long as I don't exceed that, it is fine. 2 bonds for sulfur is absolutely fine. But oxygen, okay, It's also in group 6 and it's in period 2. And because oxygen's in period 2, it has to end up with 8 electrons in its outer shell. For a group 6 element like oxygen, it's got 6. It needs 2 more. That means oxygen needs to form 2 bonds. At the moment, oxygen is only forming 1 bond. It has got to form 2, which means both of those bonds must be double. To draw that as a dot and cross diagram, I'm going to use crosses for sulfur. They are my double bonds. Now sulfur has got 6 electrons in total. I've only drawn 4 crosses, so I need to draw another 2 crosses on my sulfur. Oxygen also has 6 electrons. I've only drawn 2 dots so far, which means I need to draw another 4 dots on each of my oxygens. Next one is SO3. Again, I'm going to put sulfur in the middle. I'm going to surround it by oxygens. Sulfur can form a maximum of 6, so as long as I don't exceed 6, I'm fine. Oxygen, however, it's in period 2. It has to end up with 8 electrons in its outer shell. It's only got 6. It needs 2 more, therefore it has to form 2 bonds. At the moment, oxygen's only forming 1, so I need to form 2 bonds from each oxygen. That means I've got 1, 2, 3, 4, 5, 6 bonds for sulfur, but that is absolutely fine. Sulfur's in period 3, it can have 6 bonds. When I'm drawing this as a dot and cross, I'm using crosses again for sulfur, so there's all 6 crosses for sulfur involved in bonds. There's my oxygen. Each oxygen is only currently using 2 of its electrons, which means each oxygen will need a remaining 4 drawn. Okay, so I'm ending up with 6 crosses for sulfur, because it's in group 6, and 6 dots for each oxygen. Okay, so just do a check at the end, make sure you've got the right number of dots and crosses. Over here, CS2, so carbon is by itself. This time I'm going to put carbon in the center, and I'm going to put a sulfur on either side. Carbon is in period 2. Carbon has got to end up with 8 electrons in its outer shell. It's only got 4 electrons because it's in group 4. It needs another 4. That means it needs to form 4 bonds. At the moment, carbon's only forming 2 bonds. It has to form 4. So you're going to end up with a double bond to each of the sulfur to give carbon its 4. That gives sulfur 2, but that's absolutely fine. Sulfur is in group 6, period 3. As long as you don't exceed 6, it's fine to give sulfur different numbers of bonds. As a dot and cross diagram, I'm going to use crosses for carbon and dots for sulfur. And it should look like this. So carbon has got 4 outer shell electrons, so I've drawn 4 crosses in total. They are all involved in bonds. Sulfur has got 6 outer electrons. 2 of them are involved in bonding. 4 of them on each sulfur are not involved in bonding. CO2 is up next. Carbon in the center, oxygen on either side. Carbon has got to form 4 bonds because it's a period 2 element. Oxygen has got to form 2 bonds because it's a period 2 element. So the logical thing to do is put a double bond. Carbon, 4 electrons. Oxygen has got 6. 2 of oxygen's electrons are involved in bonding. 4 of oxygen's electrons are not. One here at the bottom, HCN. So I'm just going to draw these in the order that they will appear. But are there any double or single bonds? Double or triple bonds in there. So hydrogen can only ever form 1 bond. So I cannot put any other bonds between hydrogen and carbon. Carbon and nitrogen, they're both in period 2. So they both have to end up with full outer shells. Carbon's got 4 electrons. Therefore, it needs 4 more. Therefore, carbon must end up with 4 bonds in total. Nitrogen has 5 in the outer shell. It needs 3 more. Therefore, it must form 3 more bonds in total. Okay, nitrogen is only bonding to carbon, and if it needs to form 3 bonds in total, all 3 of those bonds must be between nitrogen and carbon. Carbon has to have 4 bonds in total, but now that it's got 3 to nitrogen and 1 to hydrogen, it has its 4 bonds in total. Hydrogen can only form 1. So your dot cross, I've got 3 elements this time, so I'm going to use different symbols. I'm going to use crosses for carbon. I'm going to use dots for nitrogen, and I'm going to use an open circle for hydrogen. Okay, so I've drawn nitrogen's 5 electrons, 3 involved in bonding, 2 not. Carbon's 4 electrons, all 4 are involved in bonding, and hydrogen's 1 electron that is there involved in bonding. Question 7, this one is maybe a little bit tricky in terms of knowing what to put in the center. So I've got H2CO, I've got 1 carbon and 1 oxygen, so you might wonder which one am I going to put in the center. General rule of thumb is the atom that can form the most bonds goes in the center. Okay, so hydrogen we know will only ever form 1. Carbon is in group 4 and will form 4 bonds. Oxygen is in group 6 and will form 2 bonds. Therefore, carbon forms the most bonds, so I'm going to put carbon in the center. So I'm going to put carbon in the center, and I'm going to put the hydrogen, and the oxygen. So they're the 2 hydrogens and the oxygen bonded around my carbon. Now I need to check and make sure I've got the right number of bonds. So hydrogen can only form 1, so that's absolutely fine. But carbon wants to have 4 bonds. At the moment it's only got 3. And then oxygen wants to have 2 bonds. At the moment it only has 1. So again, hopefully the logical thing to do there is to put a double bond between carbon and oxygen. Now oxygen is 2, carbon is 4, everyone is happy. Remember, if they're in period 2, they do have to end up with that full outer shell. They do have to end up with 8 electrons. So I draw this as a dot and cross. I'm going to use crosses for carbon. I'm going to use dots for oxygen. And I'm going to use an open circle for hydrogen. And then you can see carbon does end up with 2, 4, 6, 8 electrons. It's full outer shell. Oxygen is 2, 4, 6, 8 electrons. It's full outer shell, which is what they wanted. The next one, H2SO4. So again, this one is also a little bit tricky, but sulfuric acid is something you're going to encounter over and over again. So it's one that you will become more familiar with. So again, what am I going to put in the center? Well, I only have 1 sulfur, which indicates it should probably be sulfur. And then if I use my other rule, what element can form the most bonds, that will also be sulfur. Okay, so sulfur and oxygen, they're both in group 6. However, because sulfur is in period 3, it can form more bonds. So I'm going to put sulfur in the center. And you can do these a little bit by trial and error. So the first thing you might want to do is, right, I'm going to put sulfur in the center, and I'm going to put all of the elements around sulfur. So I've got 2 hydrogens to fill in there, and I've got 4 oxygens. I'm just going to try this, and then I'm going to check and make sure that everything's okay. So hydrogen's forming 1 bond, that's absolutely fine. Hydrogen here is forming 1 bond, that's fine. Sulfur is forming 1, 2, 3, 4, 5, 6 bonds. That's okay. Okay, it's in group 6, so it's got 6 electrons inside a shell. It's in period 3, so it can form max of 6 bonds. So it's fine for hydrogen, it's fine for sulfur. However, oxygen, because it's in period 2, it has to end up with a full outer shell. At the moment, oxygen, each of my oxygens only have 1 bond. Your oxygens need 2 bonds. All right, so why don't I just make all of these bonds here a double? All right, hydrogen's still happy. Now all of my oxygens are happy, but is sulfur happy? Now I've got 2, 4, 6, 8, 9, 10 bonds around sulfur. Okay, the maximum you can put around sulfur is 6. Because it's in group 6, it's only got 6 outer electrons. This tells me that my current structure is not right, so I'm going to have another little play around with it. Okay, so this is kind of, I know what it looks like, which helped. Okay, so what it actually looks like is instead of having all 6 atoms around it, this time I'm only going to put the oxygens around it. I'm going to put the 4 oxygens around sulfur. But I need to put the hydrogens in there someplace. Instead of putting the hydrogens on sulfur as well, I'm going to put 2 of the hydrogens on oxygen. Hydrogen is happy because it's still forming 1 bond. It's not forming it to sulfur, but that doesn't matter. As long as it's forming a bond, it's happy. Both of these oxygens have their 2 bonds, so they're both happy. These oxygens here are still problematic because they're only forming 1 bond. So I'm going to make these bonds here to sulfur a double. And now I look at sulfur. How many bonds have I drawn? 1, 2, 3, 4, 5, 6, which is also fine for sulfur. It can have 6 bonds. Now, it might not be obvious. No, it's not obvious to go from this to this. Okay, it's because I've seen this before, and you will become more familiar. It is one of the ones you just kind of have to be a bit familiar with. So to draw this as a dot and cross, I'm going to use crosses for sulfur and dots for oxygen. And there's oxygen, and I'm going to use open circles for hydrogen. So this oxygen here has got 2 electrons drawn, so I need to draw another 4 in. I also need to draw another 4 in here. So that's all this part drawn. And then down here, I've got 2 crosses here because it's a double bond. 2 crosses here. Okay, and just do a check at the end. You have got 6 electrons for sulfur. It's in group 6, so I should have 6 crosses, and I do. Each oxygen also in group 6, so you should have 6 dots around each oxygen, and I do. Oh no, I don't. No, see, that's why you check. I have 6 now around for oxygen, and then hydrogen is my open circle. It should only have 1 open circle for each hydrogen. The last one, something similar, H2CO3. I'm going to put carbon in the center. I've only got 1 carbon, and it can form the most bonds. It can form 4 bonds in total. So I put carbon in the center. Now I've got 5 atoms, 2 hydrogens and 3 oxygens. So hopefully straight away you should know you can't just put them all around carbon. Carbon can have a max of 4 bonds, so I can't have 5 atoms bonding to it. So I'm going to have to do something similar to above. So I'm going to start by just putting the oxygens around carbon like so, and then instead of putting the hydrogens on the carbon, I'm going to put the hydrogens on the oxygens. I'm going to put 1 hydrogen here and 1 hydrogen here. All of my atoms have now been drawn. The 2 hydrogens are happy because they've got 1 bond. Both of these oxygens are happy because they've got 2 each. However, carbon is still short 1 bond. This oxygen is still short 1 bond. By putting a double bond in between them, everyone's happy. Okay, and then I draw this as the dot and cross, which you can find on the answer sheet. Right, on to question 8, and this is where we encounter dative covalent bonds. And I've asked you to draw NH4+. Now, if we look at NH3 first, okay, we can see that nitrogen has got 8 electrons in its outer shell. And I told you that because it's in period 2, when it forms a molecule, that it always ends up with 8 electrons in its outer shell, just like here in NH3. Therefore, it only ever forms 3 bonds. Now I've got something NH4, where nitrogen is clearly forming 4 bonds, not just 3. So what exactly is happening? A dative covalent bond, and you're given this clue in the question, is when the electrons in the bond both come from the same atom. So if you look at the bonds between nitrogen and hydrogen, each one has 1 dot and 1 cross. The dot represents the electron that comes from nitrogen, the cross represents the electron that comes from hydrogen. So each bond has got 2 electrons, 1 from nitrogen, 1 from hydrogen. In a dative covalent bond, both electrons in the bond come from the same atom. You are told that you have a dative covalent bond, which means when you're drawing your NH4, you're going to have 3 bonds that look normal. And by normal, I mean there's a dot and a cross. And then there's going to be 1 bond that has either 2 dots or 2 crosses. This bond here is your dative covalent bond. And what's happening is that the nitrogen lone pair is being used to form a bond with an H+ ion. Okay, hydrogen's got no electrons. If it's H+, it's got no electrons whatsoever. Therefore, when it forms a bond with NH3, both electrons in that bond come from the nitrogen lone pair. Because nitrogen is contributing both electrons to that bond, it is effectively losing an electron, and the whole thing ends up with a positive charge. As you'll see, nitrogen does still have 2, 4, 6, 8 electrons, so it still does only have 8 electrons in its outer shell, even though it's forming 4 bonds. And the reason that it can form 4 bonds without surpassing 8 electrons is because both of the electrons in that 4th bond are coming from nitrogen. It's a dative covalent bond. I see something similar down here with H3O. So I've first drawn for you H2O, which is what oxygen and hydrogen normally form. So I've got 2 bonds giving oxygen 2, 4, 6, 8 electrons in its outer shell. Now forming H3O, we clearly have 3 hydrogens around the oxygen, and you are told that one of those bonds is dative covalent. So I'm going to draw the first 2 bonds as normal, and then that 3rd bond I'm going to draw as dative covalent, so both symbols should be the same. So again, I'm going to use 2 dots. Oxygen also has another lone pair. So again, even though I'm going from 2 bonds to 3 bonds, the number of electrons in oxygen's outer shell is not changing. It's still 2, 4, 6, 8, which is fine for a period 2 element. Again, because both electrons in that bond are coming from oxygen, oxygen is effectively losing an electron to hydrogen, and overall you end up with a positive charge. Okay, so it's oxygen using its lone pair to pick up a H plus ion. H plus has got no electrons whatsoever, so both electrons in that new bond coming from oxygen. Okay, so nitrogen does typically form 3 bonds and oxygen does form 2, and when they do form an extra bond, it's very obvious because you end up with a charge on the molecule. Similar story down here with H2F, okay? Fluorine in group 7 normally only forms 1 bond. It would normally form HF, which is what I've drawn below. But again, in H2F, you've got that positive charge that indicates that you're forming a dative covalent bond. So I've got a hydrogen on each side of fluorine now. And one of those bonds is normal, but the other bond contains 2 electrons from fluorine. So it's basically using this lone pair here to form a bond with hydrogen. Still only has 8 electrons in its outer shell, and now the whole thing has a positive charge. You're then asked to draw CO, carbon monoxide, and you are told that there is a triple bond, and one of those bonds is dative covalent. Okay, so I've drawn the molecule here, but we need to draw the electron. So we know carbon has got 4 electrons in its outer shell, it's in group 4, and oxygen has 6 electrons because it's in group 6, all right? And I know that I have got a triple bond, and I know 2 of those bonds are normal, which means they should be a cross and a dot and a cross and a dot. But one of those bonds is a dative covalent, which means I'm going to draw as 2 crosses or 2 dots. Okay, if I'm drawing it as 2 crosses, that's saying that the lone pair of electrons came from carbon. If I draw it as 2 dots, that's saying the lone pair of electrons came from oxygen. Okay, so I'm going to leave it the 2 different ways at the moment, but I do need to run back and fill in the rest of my electrons. So carbon has got 4 electrons. On my first diagram, I've already drawn my 4 crosses, so carbon is done. Oxygen's got 6 electrons. I've only drawn 2 dots, which means I need to draw another 4 electrons on oxygen. Down here, 4 electrons. I've currently only drawn 2 crosses, so I need to draw a cross here on the carbon, not bonded to anything. 6 electrons for oxygen, 1, 2, 3, 4, 5, and 6. Okay, so I've got 2 different diagrams, both fulfill the criteria I was given. They both show a triple bond, they both show one of those bonds as being dative covalent, and I have got the necessary number of electrons for each atom. So which one is correct? Well, we said that to form a dative covalent bond, the atom uses its lone pair to form that bond. And if we look at oxygen, you'll see that typically when you draw oxygen, it does have 2 lone pairs. Okay, it only forms 2 bonds. Normally, it's got 2 lone pairs. So oxygen is able to form dative covalent bonds. If we look at carbon anywhere, if we look at carbon here, for example, okay, carbon has got 4 electrons in its outer shell, and it always uses all 4 electrons to form bonds. Carbon doesn't have any lone pairs of electrons because it always uses its electrons to form bonds. So when you're asking yourself which element, oxygen or carbon, used its lone pair to form a dative covalent bond, that answer will always be oxygen. Okay, carbon doesn't have a lone pair to form a dative covalent bond. Oxygen does. That means this representation down here is the correct representation of carbon monoxide. Okay, almost finished. Number 11, you are asked to draw the Doncaster diagrams for polyatomic ions. This is quite tricky, okay, so don't be too disheartened if you didn't get this. What I've done, SO4 2-, the sulfate ion, is based on sulfuric acid. So if you remember, sulfuric acid is H2SO4. And it was drawn like this. In this case, SO4 minus, I've lost the 2 hydrogens and I've got 2 negative charges. So what I've actually got is I've got sulfur, double bonded to 2 oxygens, single bonded to an oxygen, and each of those oxygens now has a negative charge. You've lost the 2 hydrogens and they've left their electrons behind. Okay, so it's an acid, it dissolved, it gave 2 H plus ions. The hydrogens departed, left their electrons behind, and each oxygen that was originally bonded to a hydrogen now has a negative charge. So I need to show that is dot and cross. So I've got my sulfur here, a double bond to this oxygen. So I'm going to go with crosses for sulfur. I'm going to go dots for oxygen. So this part is going to look like this. So I should be filling those in. Okay. The second part here, I've got a single bond between sulfur and oxygen. Single bond between sulfur and oxygen. Okay. And then normally on oxygen, I would be drawing 2, 4 electrons. So I'm going to be drawing that here. 1, 2, 3, 4. 1, 2, 3, 4. Okay, and I'm just going to have a quick check to see where I'm at. Okay, so sulfur is supposed to be drawing 6 crosses, 1, 2, 3, 4, 5, 6, so that's good. These 2 oxygens, I should have 6 dots. I do have 6 dots, so that's all fine. These oxygens, I should also have 6 dots. At the moment, I've got 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So I need to have another dot on each oxygen. Okay. And then remember, you've got a negative charge on each oxygen, which means you have an extra electron on each oxygen, and I'm going to represent that extra electron using an open circle. Okay, so essentially hydrogen departed and it left its electron behind, which I'm representing now as the extra electron as this open circle, so it shouldn't be open. The rest of oxygen, all of oxygen's electrons remain, so I now have 6 dots for oxygen, 1 open for the extra electron, 6 for oxygen, 1 open for the extra electron, and that's what it should look like. This next one, AlH4 minus, I just included this one because I came up on one of the exam questions one year. Again, it's quite tricky. Your first instinct might be, I've got aluminium, I've got hydrogen, aluminium's a metal, hydrogen's a non-metal, therefore it's forming an ionic compound. Okay, it's not, it is forming a covalent molecule. The reason I know it's forming a covalent molecule is because there's an overall charge on it, okay? When you have an ionic compound, the charge is always balanced and you don't end up with an overall charge, okay? So if I have an ionic compound, something like NaCl, I never have a charge on that ionic compound because the charges cancel. In this case, I do have a charge. And the reason is because I've actually got covalent bonding between aluminium and hydrogen, not ionic bonding. So with covalent bonding, I'm going to put aluminium in the center and I'm going to put 4 hydrogens around it. So I've got 4 covalent bonds to draw. That negative charge tells me I do have an extra electron someplace as well. So I'm going to start off by drawing my covalent bonds between aluminium and hydrogen. Aluminium's in group 3. It's got 3 electrons in its outer shell. Therefore, aluminium can form 3 covalent bonds. I'm going to draw 3 normal covalent bonds, I'm sorry, that should be a cross there, between aluminium and hydrogen. So that accounts for aluminium's 3 electrons are there as crosses, and I've got 3 hydrogens with 1 electron each. Now I've got my 4th hydrogen over here, okay, and I need to add an extra electron in some place. So I'm going to add an extra electron here. I'm going to use an open circle for my extra electron, and then hydrogen is going to have its closed circle just as all the other hydrogens did. So what this kind of looks like is that aluminium has gained an electron and it has then used this electron to form a 4th covalent bond with another hydrogen. Okay. Conversely, the kind of other option is hydrogen gained an electron and it used its 2 electrons to form a covalent bond with aluminium. Okay, but either way, you've got 1 covalent bond that has the extra electron and then the normal electron. So you can draw it, actually on the mark scheme it accepted it, as long as you drew 1 aluminium hydrogen bond as dative covalent instead of just your typical dot and cross, then you were okay. Actually, this is really, no. They accepted using a different symbol, or they accepted using drawing it as a dative covalent bond. As long as one of the covalent bonds looks different from the other three, you've got your marks. The last one, CO3 minus. So again, this is similar to what we drew before. This is your carbonic acid, your CO3H2. You're losing your two hydrogens. They depart without their electrons, giving you a 2 minus charge. So if I draw this without the hydrogens and with the two negative charges, it looks like this. To draw this as dot and cross, there's carbon's 4 electrons. This oxygen here has got 6. This oxygen here has also got 6. So 1, 2, 3, 4, 5, and 6. This oxygen here also has 6. And then I've got 2 extra electrons to draw, 1 on each oxygen. So I'm going to do an open circle here and an open circle here. And they're my extra electrons. Okay, so dot and cross diagrams at A level can be tricky. I think the dative covalent ones can be tricky. The polyatomic ions can be tricky. They are only ever worth 2 marks. They are still worth being able to do, but I wouldn't get overly stressed if you're finding some of the complicated ones a little bit tricky. Okay, the easy ones you should definitely be able to do, but these kind of ones, I mean, don't get too stressed out if you're finding them difficult. I mean, there's only a few options. These are the typical ones that come up on the exam questions. But yeah, they're only ever worth 2 marks.